until now, right, all of the numbers that you've ever had to deal with are just the numbers that you know. And they are real numbers. So remember at the beginning of the year when we were classifying numbers into like rational, integer, blah, 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 I said, okay, they're all going to be real numbers because we didn't know of any others. However, there is a whole other class of numbers called imaginary numbers. And the imaginary number has the symbol lowercase italicized I. When we write it, it's like this, I like this, okay? And when we have a quadratic function, or when we have any function, when we solve for the roots, sometimes we get real roots, sometimes we might not get real roots, and that's where the imaginary numbers comes in. So why? Like, where is this even useful? So they pop up a lot when you're dealing with electricity and circuits. So when you have a circuit, right, and you've got like a power source, you've got a capacitor, you've got a resistor, and you've got an inductor or whatever. The resistances in the resistors, like when you're doing the equations, those are all imaginary numbers, right? So it is definitely used over there. Okay, so now, what is an imaginary number? Well, an imaginary number, I, is basically the square root of -1, okay? Until now, when we had, root 4, okay, we know that that's 2. But when we had the square root of -4, you were like, you can't do that. Well, now we can do that, okay? So when you have numbers that just have imaginary parts, they are called pure imaginary numbers, all right? These are examples of pure imaginary numbers. So look, you have 5i, -2 over 3i, and then here you have I root 3. So usually if it's 5, like an integer or a fraction times I, the number will come first. Only in the case of a root, we put the imaginary number first. We put the I first, and there's a very practical reason for that. So it's 5i. But if I wanted to do root 5i, sometimes it gets confusing, like the I is inside or is it outside, so it's safest to just put the I in front, okay? That's the only reason why we do that, okay? All right, so take a look at how this works, right? So until now, the square root of -9 was not possible for us to solve. But if I were to write this as -1 times 9, then it would be the square root of -1 times the square root of 9, right? And the square root of -1 is I, because that's the definition of it. The square root of -1 is always I. The square root of 9 is 3, so this would be 3i, okay? But now, if I see root -9 on my test, I don't go through this entire process. I just say, okay, what's the square root of 9? 3. There is a -3i, okay? All right, so the next one, the square root of -64, root 64 is 8, so 8i. Okay, what about this one? The square root of -18, right? The square root of 18 is what? That's 9 times 2, so that's 3 root 2, correct? But when there is a negative inside, it would be 3i root 2. Okay? The square root of -125. So the square root of 125 is 5 times 5 times 5. So this is 5 root 5. So this would be 5i root 5. Okay? Now, take a look here. I is the square root of -1. I squared, if you square this and if you square that, what would it be? -1, right? Because if you square the radical, then the radical goes away, so you just have -1, right? So take a look. If I just square this, it would just be I squared equals -1. Okay? No. Because, okay, if x is root 5, what's x squared? 5. All it does is cancels the root. So if x is the square root of negative 1, x squared is negative 1 squared, which is just negative 1. Okay, so let's take a look at this pattern here then. So I to the 1 is I squared is negative 1. I cubed is I times I squared, right? And I is just I squared is how much? Negative 1, so this is negative I. Okay? Okay, so what's I? I is just I. What's I squared? Negative 1. So I times negative 1, it's treated just like any other variable, is negative I. Okay? Now, I to the 4, let's split it up, is I squared times I squared. What's I squared? Negative 1 times negative 1, and that's 1. Okay. So now, I to the 5th, this is I times I to the 4. How much is that? I times 1, I. Okay, look. I to the 4 is 1, so this is I. Okay, I to the 6th, this is I squared times I to the 4. How much is I squared? Negative 1. How much is I to the 4th? 1. So this is negative 1. What's I to the 7? So this is I cubed times I to the 4. What's I cubed? It's negative I from up there. Times I to the 4 is 1, so that's negative I. I to the 8th is I to the 4 times I to the 4. What's I to the 4? 1. I to the 4 times I to the 4? 1. Okay? So I'll take questions in a minute. So let's take a look at this. So now we're going to repeat. We're just going to build on the previous row. I to the 9 is I times I to the 8. Okay, I is just I. What's I to the 8? 1. So that's just I. Okay, I to the 10 is I squared times I to the 8. How much is that? Negative 1 times 1, which is negative 1. Okay, I to the 11. This is I cubed. Hang on, let me finish this and then. I cubed times I to the 8. How much is I cubed? Negative I. I to the 8 is 1, so this is negative I. I to the 12, I can do it, so many different. Okay, so it's I to the 4 times I to the 8. What's I to the 4? 1. I to the 8? 1. 1. So now, take a look. Look at this. Just look at this for a minute. We have I, negative 1, negative I, 1. I, negative 1, negative I, 1. I, negative 1, negative I, 1. Do you see how it's just a pattern of 4 numbers repeating over and over and over and over and over again? Yes. So how often does it repeat? After how many? 4. 4 of them. So if I had I to the however, all I would have to do is divide by 4 and take the remainder, because after every 4 it resets and then it starts again. Okay? So here, let's take a look at this one. We're going to do I to the 53. Okay? So here's what you do. Take 53, and we're going to divide it by 4. Okay, so what do we get? 4 goes into 5 once. You get 13. How many? 4 goes into 13. How many times? 3? 1. So the remainder is 1, correct? So this is the same as I to the 52 times I to the 1. So basically you have to make the second one the remainder, and then this is the rest. Okay? I to the 52, that you ignore because that's just the resetting part. So you just take this part, and this is equal to just I. Okay, so let's do it again. 115. Divide by 4, always by 4. 4 goes into 11 2 times. So we get 35. 4 goes into 35 8 times. We get a remainder of 3. So here I'm going to take out the 3. So this is I to the 112 times I cubed. Ignore the 112. Just take the I cubed. How much is I cubed? Negative 1, huh? It's negative I, sorry. Huh? Yeah.
I was wondering of this like in the context of like smaller numbers, but like for I-10, for example, like so you did like I squared times I like to the 8, you also do like 6 and 4 or whatever. Does it have to be like
You could do it, but we don't ever, because we just divide by 4 and just take the remainder. Okay, we don't really do that anymore. We just did it for the pattern.
Do you have to show like I to the
Yes.
I to 112 times
Yes.
I to the third?
Yeah, it's like your work. It's your justification, right? It's your justification. Because you can say this is equal to I cubed, but then y, right? And this is the y part. This is the justification, yeah.
For something like I to the 6, couldn't you break that into I cubed times I cubed?
You can, whatever
Then
works.
when
It doesn't
you-
matter.
But then wouldn't you not get negative 1?
You would always get
positive
negative
I?
1. Try it. Try it. You would always get the same thing.
Because I cubed is negative I, and negative I times negative I is I.
No, negative I times negative I is not I. It's negative I squared, which is 1.
Wait, why is
Okay, let's do that later. I'll come back to it, I promise. Okay? Okay, we're gonna do a lot more right now, so just bear with me. So, okay, so look, 4 goes into 74, right? So this is gonna be 18, remainder 2, okay? So it's gonna be I to the 74 times I squared. I squared is negative 1, so that's it.
Let it be I to the 72.
Okay. 72, sorry. Okay. All right. Okay, let's move on. So let's take a look at this one now.
How do you know I is 72 is?
You ignore it. You just take the other one. You ignore the first
I
one
know, like, how do you know what I to 72 is if it's the I?
because we divided by 4, and then the quotient, when you divide by 4, you ignore it. You just take the remainder. The quotient just resets it. Okay. Okay.
I understand, but that's fine.
Okay, so when you're multiplying imaginary numbers, you multiply the coefficients and then you multiply the i's. It's just like multiplying any other variable expression. So this is going to be 12 I squared. However, I squared is how much? Negative 1. So this is 12 times negative 1, negative 12. Now, in the real world, grown-ups, we don't really write that 12 times negative 1 step. Whenever you see I squared, you just know it's negative 1, so it'll be negative 12, okay? So here, this is where students always fall into a pitfall. When you have something like this, simplify the radicals first. Trust me on this. Simplify the radicals first. So root 12 will give you 2I root 3 times I root 2. Okay?
Why is it I root 2?
Because the I comes out, the negative comes out as an I. So now, let's multiply the coefficients. I have 2I squared times root 6. 2I squared is how much? Negative 2 root 6. Okay? Okay. Now, when you multiply them out first, then you get the square root of positive 24. So all of that negative business gets lost. Okay? So please don't do that. Okay. Square root property. We know that if you have x squared something equals something, you can take a square root, you can take a square root, and then you get x equals plus or minus a number. We know this, right? So now let's do it with some negative numbers. So first, divide by 4, so x squared is negative 25. Now, take a square root of both sides, and x is plus or minus 5i. Okay? Two imaginary solutions. All right? Yes. Anytime you have a negative inside the square root, the negative comes out as an I. Okay? All right, so 5x squared equals to negative 20. X squared equals to negative 4. X is
Plus or minus 2i.
good. Okay, all right. So these are purely imaginary numbers. Now, a complex number is any number that can be written in the form of a plus bi. Now, we know math people are very specific. And so when we have complex number, this is basically a combination of a real part and an imaginary part. And it's always written in this order, a plus bi, the real part plus the imaginary part. So a is the real part, bi is the imaginary part. And these are not like terms, they cannot be combined, and we always write the real one first. So let's simplify these. You add and subtract these just like any other variable. So 3 plus 5i plus 4 minus 3i. The 3 and the 4 gives you 7. 5i minus 3i, this is plus 2i. Okay? Here, distribute. 6 minus 5i minus 3 plus 2i. So 6 minus 3 is 3. Minus 3i. That's it. Questions? Okay.
So you're not like you're
Okay.
doing like whatever the symbol is.
Right. Okay, here we have 3i times this. So we're going to distribute. 3i times 2, 6i. Minus 6i squared. Okay? So this is 6i. I squared is negative 1. So it's 15. So plus 15. Okay?
Why do you plus 15?
Because I squared is negative.
Okay. So next one. Let's do first, outer, inner, last. Okay? First, 15. Outer, negative 5i. Inner, negative 6i. Last, 2i squared, positive 2i squared. So this is 15 minus 11i minus 2. 15 minus 2, 13 minus 11i.
Why? How'd you get the minus?
I squared is minus 1.
Oh, God.
Okay, now, dividing complex numbers. Yep.
If I equals root negative 1, why wouldn't you simplify it further and do minus 11?
No, because,
Like, why do you leave that as I, but you don't leave I squared as I?
because I can't be simplified anymore, but I squared is negative 1. Yeah, but what are you going to do? Like, write it as 11 times root negative 1? That's not a defined statement. Okay?
Okay.
Okay. So dividing complex numbers. Okay, if you have simplified expressions, they are not allowed to have I in the denominator. Okay? So we have to get rid of all the i's in the denominator. Now, the way we can do this is by using complex conjugates. A complex conjugate, if you have a plus bi, its complex conjugate is a minus bi. So basically just take whatever you have and flip the sign of the imaginary part only. So if I have 3 plus 2i, what would the conjugate be?
3 minus.
3 minus 2i. Now, if I had 4i, what would the complex conjugate be?
Negative.
Correct. Okay, so now, and if you multiply a number with its conjugate, the product will always be a real number, provided that you did it correctly. Okay, so let's simplify these. Now, okay, so if you have just I, or like a coefficient and I in the denominator, you can also just multiply with positive I. You don't have to make it like the negative, right? So here I can multiply this by I over I. Remember, whatever you multiply to the bottom, you have to do the same to the top. So this becomes 2I over I squared, 2I over minus 1, negative 2I. Now that is okay, but the initial 2 divided by I wasn't, because you can't have I in the denominator. Okay, here, always put this in parentheses, and now we have to multiply top and bottom by the complex conjugate. So, in the numerator, I distribute, and I get 6 plus 3i. Okay, in the denominator, okay, listen, look very carefully at this. Look up here for a minute. We're gonna do the pattern here. This is a minus b, a plus b. So you square the first number, you square the last number, and you put a minus in the middle. Is that right? Yeah? So this becomes 6 plus 3i over 4 plus 1. How much is that?
6 over
6 plus 3i over 5. Now, remember complex numbers, it's a plus bi. Real part separate, imaginary part even like also separate. So we have to split this up and do 6 over 5 plus 3 over 5i. And before you ask me, am I going to take points off? Nobody that is in the know would leave their answer like this. So you don't want to be caught like in the math world with like something like this. Like that's just like, it's embarrassing. Okay. Okay. So now I'm going to talk about something here. I'm going to write this here and then I'm going to erase it. This is so important for me that you guys get this like, and you're super quick with this. So, okay. So if you have x plus 3, x minus 3, this would just be x squared and 9, square the first, square the last, put a minus in the middle. That's it. Now, if you have 5 plus I, 5 minus I, okay, there is a much, much, much quicker way to do this. Square the first, you get 25. Now, what's the coefficient of the I? 1. Square that, what do you get? 1. And because we're dealing with imaginary numbers, don't put a minus, put a plus, and you will just get 26. Okay? So look, let's do this one. You see how it was 2 minus I, 2 plus I? Here's how I would do this. Square the first one, what do you get?
4.
Square the coefficient of the I, what do you get? 1, put a plus in the middle, you get a 5. Okay? Why? Follow this, and you see how the negatives will cancel out. Okay? So now, let's do another one here. Okay? When it's imaginary numbers, things change a little bit, and we want to be able to use, like, especially in my honors classes, we want to be, like, you know, sophisticated, right? And so we want to be able to use these. Okay, so here, what am I going to multiply by?
3 minus 5i.
3 minus 5i. 3 minus 5i. Okay, so you know what? Let's do this more quickly. Let's do the bottom first. Square 3, what do I get? Square the 25, square the 5, I get 25. Add them. That's it. That's how quick it should be, okay? So now the numerator, negative 6i plus 10i squared. Okay, so this is negative 6i minus 10 over 34. But now I got to separate these. So it's negative 10 over 34 minus 6i over 34. But of course, simplify. Negative 5 over 17 minus 3 over 17i. Now look, before I take questions, I'm actually going to do the next one and then take questions. You can skip this step if you want, if you can just simplify in your head and go to this step, okay? But like, you know, okay, like that I'm okay with. Okay, let's do this one. What am I going to multiply by?
1 plus I.
1 plus I. 1 plus I. Okay, let's do denominator first. It's quicker. Square the 1, you get a 1. Square the 1, you get a 1. Add them. Okay, let's FOIL the top. 2 plus 2i plus I squared. Go slow on those. Okay, we're just learning. Don't be so quick. So this will give me 2 plus 3i minus 1 over 2. 1 plus 3i over 2. 1/2 plus 3 over 2i. And normally we do write the fraction and then the I. Like it's not wrong, it's just convention. I mean, you know, it's like an unwritten law or something. I don't know. I think people did it enough times that it's just like law now. Okay? All right. Now, question very quickly and then I'm going to move on. Yep.
First seat, when you did like the distribution on the denominator, like why did you get 25 and not 25?
Okay, later. Because I went over it a couple times. Okay, yes.
I wanted to ask why on C when it says 10I squared, how it goes to,
Yep, okay. All right, so complex expressions can be set equal to each other. If you have two complex expressions that are equal to each other, you can set the real parts equal to each other and you can set the imaginary parts equal to each other. Okay? So find the values of x and y that makes this true. In order for this to be true, the real parts have to be equal to each other and the imaginary parts have to be equal to each other. So what are the real parts here? This and this. These are the real parts. So let's set them equal to each other. What are the imaginary parts here? Basically the coefficients of the i's. Okay? So solve these. I'm going to do the x first.
why did we get rid of the I?
Because they cancel, the coefficients have to just be equal to each other. So x is -1, and here y equals -9. Cool? Okay, and that's